Welcome and thank you for your interest in my 3D printer construction project. I'm aiming to build a Delta printer with some special features which I will discuss along the way. What you're seeing at the moment is a simulation of the design that is using the parts I've modeled so far. You can find the source code for all of the parts on GitHub, but be aware that you're actually seeing this build as I go along myself. There is absolutely no guarantee that it will all work out exactly as planned. Since this is my first self-designed printer, I'd even say it's highly unlikely. But enough of the apologies, let's get to work. A lot of parts needed to be printed and prepared before I could start assembling the main frame. I started with the belt tensioners that hold the idler pulleys at the top of the vertical axis. These parts do not require any support if printed in this direction. The horizontal holes need to be reamed to 3 mm, the vertical hole to 4 mm. A quick touch with the file ensures that no burrs remaining on the inside will be in the way of the components installed there later on. Here's the hardware required to assemble the tensioners. I started with the M4 nuts that will hold the tensioner on the vertical adjustment screw. There's a hexagonal inset on the inside of the tensioner bracket that will prevent the nuts from turning loose later on. For easier assembly, I glued them into place with a drop of superglue and then carefully removed the screw I used to pull the nut into the recess. Now for the idler. I first used a precision oiler to lubricate the F623 ball bearings. The factory goo they were covered in did not really inspire confidence. 2 of these bearings placed back to back with a washer in between make up a decent idler. 2 additional washers prevent the ball bearings from sticking to the printed bracket. An M3 screw and 2 lock nuts complete the assembly. Getting the parts in there can be tricky and time consuming, and since it's only slightly more interesting than watching paint dry, I cut out most of that. It is important to leave enough play on the screw so that the idler components can turn freely, but still lock the 2 nuts securely. The idler will move a lot, and any single or loose nut would certainly come off at the most inconvenient time. Next up was the end stop switch assembly. Like the belt tensioner, its height can be adjusted with a screw, but since there's no belt pulling it down, it will need a spring to keep it securely in its position. I'm using the standard SS5GL end switches. Since I wasn't able to source connectors of the right size for these contacts, I simply soldered the leads onto the switches directly. The brackets have a solid block at the top with a vertical hole that needs to be tapped to accept an M3 screw. I've had little luck with the combination drill tabs for machine use, so I went back to the proven method. Pre-drilling to 2.5 mm, then tap using manual tap wrenches. I then mounted the switches to the brackets using 2 M2x10mm self-tapping countersunk screws. Now for the opposite end of the frame. The printer will rest on 3 adjustable feet that will allow for the frame to be leveled. The feet use a standard M8 screw and are octagonal so they are easier to adjust manually than round feet. I've decided to put a special rubber foam padding underneath the feet, both for acoustic insulation and to keep the printer from moving around. Again I reamed the holes and then glued the screws into place with superglue for easier mounting. Then I placed the padding underneath the feet. At this point I realized that the superglue bonds probably would not be able to hold the weight of the printer and any lateral forces would break the screws free. Therefore I added some washers and nuts to lock the screws and printed feet tightly together. After cutting the padding to size, the feet were complete for the time being. Next up was the bottom frame bracket that will connect the vertical extrusion with 2 of the lower horizontal extrusions and at the same time hold the foot we just assembled. This part is best printed upside down, but remember to add support structures for the little tabs on the inside. We'll see what these are for in the next video. These are the printed brackets and they are supposed to hold the feet like this. Again, the holes needed to be reamed. The frame holes will hold M4 screws and the bottom hole will be tapped to M8. Before doing that, however, I checked whether the brackets fit the Makerslide extrusions. I'm using an offcut that I got from my supplier for free to avoid damaging my production rails. As for the tapping, you know the drill. The tap, I mean. Whatever. After deburring the holes, the feet fit just nicely. Next up was the motor bracket. I'd recommend to print it upright like this. It does require a bit of support either way, but in this direction the support is easy to remove and won't leave any ugly marks. This bracket will have to bear a significant load due to the tension of the belts, so printing it as solid as possible seemed like a good idea. I'm using NEMA 17 motors, the 400-step variant that is 0.9 degrees for increased precision, with some standard 20-teeth GT2 pulleys. First, I checked the maker slide fit as before. These brackets needed a little percussive persuasion, but in the end fit on nicely. A tight fit is obviously very desirable here. Then I reamed the extrusion side holes to 4mm and the motor mounting holes to 3mm. Since the brackets form an electrical insulator between the motor chassis and the rest of the frame, the motors need to be grounded to prevent a build-up of static electricity. That's what these separate grey cables are for. I've crimped on some terminals to get a good connection. Before mounting the motors to the brackets, I installed the GT2 pulleys with the teeth facing outward about 2mm from the end of the axis. Finally, I screwed the motors to the brackets. I used some washers because the screws were a tiny bit too long. Now for the middle bracket. This one will hold the horizontal extrusions that in turn hold the bed. For these brackets, I just had to ream the holes and check the maker slide fit, so let's move on. The last bracket is the most complex one at the head of the vertical rails. It will hold the tensioner and end switch. This bracket is best printed upside down as well and requires a bit of support for both the tabs on the inside and the horizontal extensions. By now you know the drill: reaming the holes and the maker slide extrusion slot. Now I was able to install the idler using a long M4 screw and a washer on top. Oops! That superglue bond wasn't up to the task, it seems. At least you can see what I meant when I said that it was awkward to mount. Or you could see it if I could make my autofocus work by swearing at it like some people apparently can. Oh, and framing, of course. Now for the end stop switches. Again, I'm using a long screw with a washer for adjustment. I'm using the springs that can be found in many printers for the bed adjustment, and I've placed a large washer on each end to distribute the pressure across a larger surface area. To spread out the load along the entire tapped thread, I've screwed in the end stop until the screw just reached the end of the tap block. And that's the head assembly done. Now for the last part on the vertical rails, the carriage. This part is best printed lying on its backside, and I've increased the resolution for the ears that hold the steel balls. Don't worry about the screws and belts for the moment. Most of the reaming work is straightforward, but the single hole on the right side has an unusual diameter of 6.9mm, and it's important to get that diameter as precise as possible. So I ordered a special drill just for these 3 holes. The small holes in the center are tapped with an M3 thread. I'm not sure whether I will need it, but it would be much harder to tap the holes once everything is mounted. Now, to mount the steel balls that will be part of the upper joint, I've placed the printed parts upright in a vise. Before mounting the balls, I've used some acetone to remove all traces of oil or other manufacturing residue to ensure a good glue bond. Then I used superglue to fix the balls to the carriages. Unfortunately, I managed to get my head in the way of the camera. Anyway, once the glue had set, I could remove the pieces from the vise and mount the wheels. For the single wheel on the left hand side, a special eccentric spacer is used to make the wheel adjustable. To mount the wheels, I used M5 screws, longer ones for the wheels with the spacers. Ignore the large washers, that didn't work out. To secure the screws, I've used self-locking nuts with a nylon ring. You really wouldn't want the wheels to wiggle themselves loose. I applied some oil to the ball bearings inside the wheels as well, then mounted the wheels. I started with the fixed wheels. A washer on each side ensures that the ball bearings don't stick to anything. Now for the adjustable wheels. I pressed the spacer into the hole in a tight fit, then added a screw, a washer, a regular one, and the remaining parts. Once the wheels were mounted, I used a Maker Slide offcut to check the fit. And that's it for today. In the next video I'll assemble some of the parts. Let's see how far we'll get. In the meantime, if you have any comments, please leave them below, and please subscribe to get notified of new videos. See you later!